if you had 5 minus 3t, 5 minus 3t,
You write it. I was.
then the coefficient in that expression on the left is -3.
Right.
Right.
So they're asking, but I thought that was a minus sign.
And it
A
is.
subtraction sign. And I haven't had to explain yet how you deal with it.
But like you just said, this is 5 minus 3t. But if we're talking about coefficients and constants, the coefficient is
-3.
negative.
But you know, when I teach and correct at the very first week, that's one of the things I do address first week of school is when we do integers, because I try to teach to help them with integers and teaching them the box method and stuff. I teach them not to really see subtraction as subtraction. Actually, at this point in the game, whenever you see a subtraction, you really should think of it as a negative, like it is a negative.
Adding the.
Right. So, and not even adding the opposite. So, for instance, so Christy, do this, subtract 5 from both sides.
And some kids, because they think that coefficient is +3, they would subtract 3 on both sides and not add.
Right. So then when you bring it down, you bringing down a -3t. And then you have to have the conversation, well, what does -3t mean?
Right.
Because you have to have that discussion, because you got to help them transition from one to the other. That's -3 times t. Right.
But
And
you
that,
can
goes,
see
and that
how,
goes back to,
Yeah.
understanding that is a product of
Right.
-3
And t.
but you can see
I tell
how
my
it would
kids
be
they would probably never
confusing
see a
because
multiplication sign again.
in
Not
the
there in high
first
school.
blue equation, that was -3t. So you can see how it would be crazy making. It's like, oh, so I'm not gonna add 3t to both sides? Well, you could, but it doesn't help you any, you know?
Because all you're doing is moving it to the other side. You still got to
Right.
get rid of the
The
coefficient.
exactly.
But so
But when
so
they
I so.
move it, they're gonna make it 15.
So see, that's the difference. That's what I'm saying. I see 5 and -3t. Because when I teach integers, like, so I don't say, I rarely say minus. And again, with integers, because I'm holding and talking. Your turn to hold while I talk. So again, with integers, so they tend to have the issue when it's something like this, right? Okay, so the minute, which I tell them, when you say -4 minus 7, the minute you say minus, your brain is already subtracting, because it's a self-taught thing. I mean, it's just what it is. So you're already subtracting, but technically, I have 4 negatives and 7 negatives. How many negatives do you have in all? 11 negatives. So I rarely use subtraction or minus even when I'm talking, to try to get them into the habit of seeing, particularly when you start getting into equations and they look funky. Is okay, I have 12 positives and 5 negatives.
Right.
I have how many more positives? 7. So here I have 5 and -3t.
So are they able to do that without using like little manipulatives first?
I don't really do a lot. I've never used I've never used advertising, so I just haven't.
Or just even.
I mean, I know they say they work with, but for me, the kids just, they can do it while they sitting there doing them, but then the minute it transfers, right, I gotta remember that these were long rectangles, these were little bitty squares. I mean, you know what I'm saying?
And then for those kids
I
that have
teach
it.
the mathematics. It goes back to, for me, it's the math. What you're doing when you're doing integers, you're just combining something that's different or either alike. And just like elementary, 2 red cars, 3 red cars, 5 red cars. And for a lot of students, that really does click. I mean, you might have a lot of little circling boxes, but a lot of them that it click, they'll use it. So, but this does cause an issue, like you said. But I was very surprised. A lot of my kids today did, they were able to, it was the writing and creating equations that was more so a problem than the solving. And of course, a lot of them could solve the problem in their head.
Yeah.
You know what I mean?
Yeah.
But couldn't, because the boy's like, oh, it's 125. I was like, where's your equation? He was like, that's why he couldn't do dimensional analysis, because a lot of the problems with dimensional analysis, he's been doing in his head. And then when I go to check his work, it's like scribble scrabble all over the place.
Yeah.
You know what I'm saying? He's doing a little math here, a little math there, and then trying to put the two together. So, and I told him, I said, but the test can't degrade your thinking. So, I'm have to force him, he got to force to be made to show the work and write. So,
Can you do that, probably Dr. Starling was saying, can you erase the black? Because I had one student that actually.
On both sides?
Yeah, everything everything below. What he did, for example, he added 3T on both sides.
Oh, yeah.
Mm-hmm.
And then he ended up with 5 equals 3T plus 12. And then he was able to solve it easier.
Because there were no negatives.
Because there were no negatives.
Yeah.
And also,
And I think that that's okay.
And it's
I mean, it's okay.
But if you think about it, if you subtract 12 from both sides, it's gonna give him back to a negative. So then what?
No, but he can handle a negative without the variable.
Oh,
Yeah.
so just the
so not
coefficient.
negative coefficients.
Right, because remember, variables can't be negative, so that's another whole thing. For him, he's always in the mindset of making, somebody done taught him,
Right.
always make your variable, a middle school teacher has taught him to make his variable positive all the time. Because they do, and that's what they do.
Yeah.
That's another thing they do with trying not to put too much on them in terms of thinking. But see, now you see once they get to us, it's like, oh my God, where did this come from?
And I explained to him that what he did is correct. The only thing is, you have questions that says, here's the equation, what's the first thing to do?
Right.
And even though your first thing is right, they're not expecting that first thing.
Right.
They're expecting you to get rid of the constant first before you go with the.
And so did y'all have the kids that did this with the shoe problem?
No.
No, I didn't have that.
What was it, minus 25 equals the 3, or he had the 3x, oh, this what it was. Yeah.
So 2 variables?
No, oh, not 3, well, so what was that problem?
Plus 3.
3 minus 3, the x should have been, the d should have been with the 3.
And I think just understanding what
The total
is being
cost.
multiplied. So you're multiplying the number of shoes by the cost of each pair.
Yeah, because remember we went through and said D was the cost of each shoe.
they started.
400 was the total. But see, I had told them we have 2 totals. Because remember, one part of it said $25 left. So I said, so we either have 400 or 25. So they put both of them after the equal. So that's why he came up with this, because I had said that there's actually 2 totals.
So
then
you
I had
could
to
have
make them
subtracted the
right, so they
3x.
represent. So and then it got down to, well, what does the 3x represent? Because I said, how we get to 25? What did this 25 even come from? Where did it start? They was like, it was part of the $400, right? So then, what else should be over here? So when but 2 of them did this, about 3 of them put it on the board. This same thing right here. And I said, but remember, this was the cost per shoe. So you're saying we had 400 pairs of shoes? And he was like, oh, yeah. So, that one was kind of surprising though. I was like, wow. Considering when we say the total, the total, we have already said that the totals were 425. You could
So
have
are
painted
you-
that somebody else.
When you introduced this, did you use inverse operations, or did you use the order of operations to
Okay, like that
go
problem, we have
backwards?
5 minus 3 equals 12. So we're gonna subtract 5 on both sides. Do you have kids that are subtracting 5 from 5 and subtracting 5 from negative 3?
No, I didn't see that. That's why I said this group of kids really, I didn't see a lot of the common stuff you normally see.
And I'm looking for 15T.
Right.
I haven't seen that yet. But we haven't really had any problem where they would have to do that yet. But no, I was surprised that most of them started off with 400.
Right.
So just some misconceptions that we just want to think about ways to try to clear them up. Like I said, when I saw this today, I actually showed this paper first and had the kids talk about, what was right, what was wrong, because there was right. And so I wanted the kid to think, okay, it's wrong, but your answer is correct, but your process is incorrect, and how you wrote it was incorrect.
And that's what I'm doing a lot of this year. Instead of giving my feedback, I
Let the
allow
students.
classmates to get feedback.
So,
Tell her I emailed her the quiz.
So does anybody else have any misconceptions that they want to discuss? So, think of some ways to try to clear them up, since we're just starting with the equation.
I have a question. So
I'll
are
have an
you,
answer.
okay, so are you?
Yeah, right. Yeah, that's what I say.
Done this. Thinking about doing it, I would be working with inverse operations. And I know in the past, we've also connected that to the order of operations and doing things in reverse.
Mhm.
Is that how you're looking at it
Yes.
right now?
Cause we actually even talked about inverse operations
Mm-hmm.
before we even did
Yeah, right.
the note.
And also, I was thinking, since we're seeing all of these misconceptions, maybe we could do error analysis with these wrong, steps and have the
Mhm.
students see it.
Right.
And fix it.
And like I said, that's why I purposely showed this first before I showed the correct answer, so that the kids could see. Because as soon as I put, someone's like, oh, that doesn't look right. Something's not right. Okay, well let's talk
Mhm.
about it. What's wrong with it?
Yeah, and I had my kids come to the board so everybody could already, they could all, and they was already like, wait, you know what I'm saying? Like, particularly that 400D one, everybody was like, wait, the 400, because we had did the sheet, and they was like, but 400 is a total, and so it should be after the equal sign, not, and so, you know, they did put all that together from doing that graphic organizer that you gave.
Does that answer your question? Any other misconceptions? So I put this article here.